Have you wondered why we are getting sick earlier, dying of heart attack at early age, kidney failure, and even cancer? Imagine a glistening drop of seed oil or vegetable oil filled with energy-rich molecules called lipids. These industrialized, ultra-processed oil treated with chemicals oxidize easily to become poison to our cells and stay in our body for months to 2 years. As we swallow, this drop embarks on a remarkable journey through our digestive system. In the small intestine, bile salts break down the large oil droplets into smaller pieces. This allows special enzymes called lipases to get to work. These lipases break down the lipids into smaller molecules, fatty acids and glycerol. These smaller molecules are now ready for their next adventure, entering the bloodstream. The lining of the small intestine absorbs the fatty acids and glycerol. These molecules then enter the lymphatic system. The lymphatic system is a network of vessels that carry a fluid called lymph. Lymph carries the fatty acids and glycerol towards the bloodstream. Finally, these energy-rich molecules enter the bloodstream, ready to be transported to cells throughout the body. Our cells are encased in a thin, flexible barrier known as the cell membrane. This membrane is made up of phospholipids, molecules with a structure similar to those found in our drop of vegetable oil. The fatty acids and glycerol from our digested oil can be incorporated into this dynamic membrane. They squeeze themselves between the existing phospholipids, making the membrane more fluid. This increased fluidity has important consequences for how the cell functions. It affects the activity of proteins embedded in the membrane, including those involved in sending and receiving signals. One crucial type of protein affected by changes in membrane fluidity is the voltage-gated calcium channel. These channels act as gatekeepers, controlling the flow of calcium ions in and out of the cell. When the cell membrane becomes more fluid, it can change the shape and activity of these channels. This change can cause the channels to open, allowing calcium ions to rush into the cell. This influx of calcium ions is a critical signal within the cell. Calcium is a crucial signaling molecule within cells, regulating functions such as muscle contraction, nerve transmission, hormone release, and cell survival. However, when calcium enters the cell in excessive amounts, often referred to as calcium overload, it can trigger a cascade of harmful effects. These include mitochondrial dysfunction, oxidative stress, the activation of destructive enzymes, and eventually cell death through apoptosis or necrosis. Over time, these disruptions can contribute to the development of chronic diseases.